In this video, we are going to explore how to go about naming carboxylate salts, such as how do we relate the name sodium benzoate, which is a common food preservative, shown in the powdered form here, but generally in foods it's fully dissolved to preserve common drinks and other substances that are heavily preserved. How do we go from the structure of sodium benzoate to the name, or vice versa? We're going to learn that for a variety of different carboxylate salts, which play important roles biologically and are much more water-soluble than their carboxylic acid counterparts. Let's go ahead and take a quick look at how to name these molecules. Due to the fact that these are completely related to carboxylic acids and that carboxylate salts are formed by just removing a proton from the carboxylic acid COH group, carboxylate salts are named with respect to their carboxylic acid counterpart. So in order to name carboxylate salts, what we are going to do is we would use the IUPAC rules to name the carboxylic acid that is derived from the carboxylate salt. We'll do that just as we learned in video 366. Then, since we are naming a carboxylate salt rather than a carboxylic acid, the suffix on the parent name is not oic acid to denote that the molecule is a COH group, but instead it's going to be ATE to denote that the molecule is instead a carboxylate salt. So rather than oic acid, which is our telltale sign that we have a COH group in the molecule, instead the ATE suffix denotes that we have a COO-, that is a carbonyl group directly bonded to an oxygen anion in our structure. And then finally, since these are salts, they have a counter ion, a cation, that goes with the negatively charged oxygen. That cation is going to be an atom from the first column of the periodic table. So that could be, for example, sodium, lithium, potassium, or others from that first column of the periodic table that adopts a +1 formal charge to counter that COO- group. So we have here an example molecule. The first thing that we need to do as we think about nomenclature is recognize what functional group we're actually going to be naming here. So we have a molecule that will have as its parent name this functional group that has a COO- group bonded to a lithium there. This is going to be our ionic bond right here, is the lithium cation bonded to the oxygen anion. Oxygen being way more electronegative than lithium, this is going to be an ionic bond with oxygen having a negative charge, lithium having a positive charge. In order to name this, going with the first rule here of naming the carboxylic acid using the IUPAC rules, what we will do is we will name it as if this lithium were instead a hydrogen of a carboxylic acid. So for step 1 of the nomenclature system, what we do is envision that COO- lithium plus is a COOH group. If this was a carboxylic acid, the name of this molecule we would derive by coming up with the longest carbon chain starting at the carboxy group. That's 5 carbons following our longest carbon chain. And if we had 5 carbons in our longest carbon chain, the parent name for this becomes pentanoic acid if this was indeed a carboxylic acid, oic acid, denoting to us the COOH group. And then specifying the names and locations of all of the branches. We have a branch at position 4, and that's a methyl branch. So we would refer to this molecule by name as 4-methyl pentanoic acid. Now, in this case, though, it's not a carboxylic acid. Instead, it's a carboxylate salt. And so what we do in this case scenario, following the IUPAC rules, we're going to replace the oic acid of the corresponding carboxylic acid with 8. So I'm just going to rewrite the name that we have come up with for the carboxylic acid, 4-methyl pentanoic acid, and change it into 4-methyl pentan O8, where that ATE suffix takes the place of oic acid since we no longer have a COH group, but instead we have a COO- group. And then at the very front of that name, as our last step of nomenclature here, we have to add the name of the cation that appeared at the beginning of the structure. And that, in this case, was lithium. So we would call this lithium. And then there would be a space between lithium and 4-methylpentanoate as the correct name for this molecule. So in the case of this carboxylic acid salt, or carboxylate salt, as we can also call it, the full name for this would be lithium 4-methylpentanoate. We arrived at that by coming up with the name of the corresponding carboxylic acid, meaning if we, instead of having this oxygen anion here, if instead we had a COH group, what would the name of the molecule be? And then to convert that into the carboxylate salt name, we put in the name of the cation, lithium, sodium, or potassium most commonly. And then we go ahead and come up with what the name of the carboxylic acid would have been, but rather than ending the name with oic acid to show that it was a COH group, instead we end it with O8, O-A-T-E, to indicate that it is a carboxylate salt. Now, with that information in mind, we can return to the title slide information where we saw the structure of sodium benzoate, and we can now understand why that compound is named sodium benzoate. Sodium benzoate has the COO group directly bonded to a sodium here, and thinking about the nomenclature that we've learned here of carboxylate salts, we recognize this as a carboxylate salt because it has a COO minus bonded to a cation, sodium. The name sodium benzoate, from that name, the sodium, comes from the fact that we put the name of the cation at the beginning of the name of these carboxylate salts, hence sodium. And then the name benzoate arises because if this molecule was instead a carboxylic acid, where we had an H here, in that carboxylic acid, Ca, as I'm abbreviating it, rather than the sodium that is present in the salt form. If this was a carboxylic acid, an aromatic ring bonded to COH is referred to as benzoic acid. And so benzoic acid, when it loses that proton by reacting with a base, becomes sodium benzoate. And indeed, the industrial process for creating sodium benzoate for food manufacturing relies upon taking benzoic acid and reacting it with a base to create this salt molecule. Now, you might be saying to yourself, as you look at the structure of sodium benzoate, you might be thinking, is that dangerous in food? Because I've perhaps heard that benzene can cause leukemia, and benzene is quite a toxic, nasty substance. And so what about sodium benzoate? Well, with organic molecules, there is a very intricate relationship between the structure of a molecule and its biological properties. And by attaching the carboxylate group onto a benzene ring, the benzene molecule no longer is able to cause leukemia, generally, as currently known in the scientific literature. So sodium benzoate has very different biological effects than benzene due to the fact that it has this relatively polar carboxylate salt group added to it. So in the field of organic chemistry, making pretty subtle changes to the structures of organic molecules can lead to pretty dramatic changes in how the molecule interacts with biological systems.